Hello everyone. Let's begin with a simple but powerful idea. Whenever we light a bulb, switch on a fan, or even lift a book, we're using energy. But how do we measure this energy? Just like we use meters for distance and kilograms for mass, we have standard units for energy. The most common and universally accepted unit is the joule, and symbolized by capital J. In the centimeter gram second system, or CGS system, energy is measured in a smaller unit called erg. Here's a key relationship you must remember. 1 joule equals 10 raised to the power 7 erg. That's 1 joule equals 1 followed by 7 zeros erg. A huge difference in scale. Now why is this important? Because accurate units help us calculate how much energy something uses, from running a machine to boiling water, or even fueling a rocket. Now that we know the standard units, let's move to something more relatable, like your electricity bill. Ever seen the term watt-hour or WH printed on it? A watt-hour is the energy consumed when a device uses 1 watt of power for 1 hour. Let's calculate it. 1 watt-hour equals 1 watt multiplied by 3,600 seconds, since 1 hour has 3,600 seconds. So 1 WH equals 1 W into 3,600 seconds equals 3,600 joules. That's how much energy your 1 watt LED bulb uses in an hour. This unit is especially useful for measuring household electricity usage, helping us track how much energy we consume daily. Let's now scale up, because homes and factories don't use just 1 watt or one device. That's where the kilowatt hour, or kWh, comes in. The commercial unit of energy. 1 kilowatt equals 1,000 watts. So 1 kilowatt hour equals 1,000 watts multiplied by 3,600 seconds, which equals 3.6 into 10 raised to the power 6 joules, or 3.6 megajoules. This large unit helps measure energy used by machines, industries, etc., and even the entire city. So when your bill says you used 100 kilowatt hours, it means you consumed 100 into 3.6 million joules of energy. Now let's revisit our standard systems, SI and CGS. In the SI system, we use Joule. It's widely accepted and easier to work with when dealing with large energies. In the CGS system, we use erg. Let me give you the conversion again. 1 joule equals 10 raised to the power 7 erg, or in words, 1 joule equals 10 million erg. Why use different systems? Earlier scientific experiments used CGS units, especially in classical physics. But today, joules dominate in engineering and industry for clarity and global consistency. Now let's talk about something close to our plates, the calorie. Yes, the same unit we see on food packets is actually a unit of heat energy. A calorie is defined as the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius, from 14.5 to 15.5 degrees. It's commonly used in thermodynamics and nutrition. Let's do the conversion. 1 calorie equals 4.18 joules, or 1 joule equals 0.24 calories. And a kilocalorie, often written as kcal on food labels, equals 1,000 calories, which equals 4,180 joules. So when you eat something worth 200 kilocalories, you're actually consuming 200 into 4,180 joules of energy, which your body can use for motion, heat, or storing fat. Alright, now let's clear up a common confusion, energy versus power. Energy is the capacity to do work. Power is how fast that work is done. Let's say 2 people lift the same weight to the same height. They both use the same energy. But if one person does it faster, they use more power. Energy is measured in joules, power in watts. And the relationship is power equals energy divided by time. So if a machine uses 3,600 joules in 1 hour, its power is 1 watt. Think of energy as the amount of fuel and power as how fast you burn that fuel. Let's quickly wrap up what we've learned about units of energy. We started with Joule, the SI unit, and erg from the CGS system, where 1 joule equals 10 raised to the power 7 erg. We explored watt-hour and kilowatt-hour, with 1 Wh equals 3,600 joules and 1 kilowatt hour equals 3.6 into 10 raised to the power 6 joules. We introduced calorie, used in heat and food energy, with 1 calorie equals 4.18 joules, and 1 kilocalorie equals 4,180 joules. And finally, we compared energy and power, energy being total work capacity, power being the rate of doing work. I hope this journey helped you see how energy flows across devices, fuels our machines, and even powers our bodies. See you in the next session with another concept that lights up our understanding of physics.